Hi friends, welcome to follow up. Let's have a look at problem 2816. Double a number represented as a linked list. So in this video, we're going to explain a solution by directly modifying the node values. So here we are given the height of a non-empty linked list representing a non-negative integer without leading zeros. So we want to return the height of the linked list after doubling it. So here doubling means that we multiply the number represented by the linked list by 2. So here are several examples. So in example 1, so the number is 189. So after we double it, it's going to be 378. And then we output it as a linked list. So this is the example 1. So you can interpret example 2 similarly. So here the constraints are the following. First, the number of nodes in the list is given by this closed interval, and each node value is a digit. And the input is generated such that the list represents a number that does not have leading zeros except the number 0 itself, right? So with that said, we are ready to do the analysis. So basically, there are two strategies for this problem. The first one is a naive one. So we can get the integer represented by the linked list and then multiply by 2 and convert the number to be a linked list format. So this is the first strategy. And the second strategy is a little bit better. So we can modify the nodes values directly. And in this strategy, we could write some hyperfunctions to achieve this. For example, reverse a linked list or double the value by modifying the linked list values. So here we're going to do the second for practice, and we leave the naive one, the first one, as exercise. So with that said, let's move forward. So here let's first write a function to reverse the linked list, because we are going to directly modify the values. So we'd better to use the least significant digit as the height of the linked list. So let's achieve this. Let's first reverse this linked list. So here I'm accepting a height, which is something like this. The height is the most significant digit. We're going to reverse it as 981. So this actually is a very routine task. Here let's use a pre and current to be height and height next. So here I'm going to use this initialization is due to the assumption that the number of nodes in the list is in this range, at least one node, right? So then what we want to do, let's first break the cycle, because we want the previous next, we want to set it to be a none, right? So because we already have the head next, right? So this is to eliminate possible cycles. Then what in order to reverse the linked list, it's just a for loop or while loop. So while current, so let's first get the current next. So because this condition, we can do this. We can retrieve the next attribute for this current. And then what we want to do is we set the current next to be previous. And then previous, we update previous and current. Previous to be the current, and the current to be the temp, right? And then what we want to do is to return the previous, because after we exit this while loop, current will be a null, right? While the previous will be the last non-null node. This will be the representation of the linked list reversed. So basically, this is the first step. So basically, we can print out this just for a demonstration. So let's look at one example. Let's run this code. So we have 999, right? So after we reverse, we still have 999. Let's look at 178, just for example. So we are going to have 871. So this is the first step. So now let's look at the second step. So we want to double the number represented by the linked list. So here we have height. So notice that we assume that this height represents a digit with its least significant digit being the height. So for this, actually, I'm going to use a dummy index again. So list node, I'm going to use 0, right? And then dummy next, we're going to connect with the head. So basically, we want to compute the carry, right? So this is very standard. So let's use this Q as carry. And then previous, we'll use it as dummy, right? And then current, we are going to set it as the head. And now we want to iterate. So while current, so we want to multiply the current value by 2, right? So the current carry or quotient, current R will be something like this, def mode. So we want to this value multiply by 2, and then we want to add the previous Q state, then divide by 10. So the remainder R will be the current node value, and then we want to reset the Q to be the current Q. You can understand this Q as carry, right? Then we just need to modify the value, right? Current value to be current R, and then Q to be current Q. And then we move the pair of current and previous one step further. So in other words, we set previous to be current and current to be current next. So this way, we need another check. After we exit this while loop, the current will be null, while previous is not null, right? We want to check if we want to have an extra node, because this corresponds to Q not equal 0. For example, in this example, we're going to have 4 nodes with a 1 here. So let's see if Q is not 0, right? So we're going to set previous next to be a list node with the current value, right? And then what we want to return is the dummy next. But notice that this is double the return. So still the head is the corresponding least significant one. We want to do reverse. So this is actually simple because we have already implemented this reverse function. We just need to call it again. So now let's look at the logic for this problem. So what we want to do, let's see, we have first get the reverse height. It's going to be reverse of the height. And then we can get the multiplication, that is double, right? Double the reverse height. And then we just need to call the reverse again, right? This will give a list height, linked list height. We just need to return this one. So this actually forms a solution format to this problem. So before we make any comments, let's first do a test. Yeah, it passes the one example we cooked up. So now let's look at the second example with none, 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 or you can add one more if you like. So let's do a test. Yeah, it passes this one. So now let's look at the generic case. Yeah, it passes all the generic cases as expected. So here in this video, so actually we directly do the second way. We modify the node values directly. So here of independent interest are the two hyperfunctions. One is reverse, one is double. So actually it's good to practice this kind of utility functions and use them to solve general questions. And as an exercise, you can do the first one. So this is very straightforward, but pay attention to the case when the number is 0. So with that said, basically that's about it for this video.